All right, guys. We are live. I am going to mute my live stream so I don't get feedback. Uh,
YouTube should also give notifications to people too, and of course I yell, "We are live!" Exclamation mark! Exclamation mark!
all right, we are live indeed. Welcome everyone. Today
Everyone.
we've got an
Hello.
exciting live stream office hour. We've got obviously Arthur here, but more importantly, we've got Han Shu, who leads Airbnb's data science. I've known Han for a number of years. Han is a native Bostonian who decided to escape the Boston winter. That was the right decision, by the way, because
Very
we've got
smart.
2 feet of snowbanks, ice banks. So we're very excited, Han, to have you.
I don't lead all of Airbnb's data science. Data science at Airbnb is pretty big, but I lead a few groups. So.
Yeah, that's great. We'll want to talk about what you do there. Maybe a good way to start, Han, floor is yours. I'd love to hear your intro, your background. I think people are very interested in sort of what you've done before and your role at the Airbnb.
Sure. So I started out my, I guess, academic life in speech, and where Arthur and I actually worked at the same place, BBN. That was our DARPA-funded speech recognition site. And so I did speech both at MIT and at BBN for quite some time. And this was before the deep learning days for sure. And so we're using HMMs and finite state transducers and straightforward n-grams. And then after graduate school at MIT, I joined Mike Phillips, who started Speechworks previously, and to start a new venture called Vlingo. And there so this is 2006. It's kind of almost seems like impossible that the days before iPhone and Android, where the most popular smartphone was BlackBerry, and where people downloaded probably 0.1 apps per year on average per user. And J2ME was still around, and that was probably the easiest way to install apps. And but at that time, we really had this vision that we want to build the easiest voice-based user interface possible for mobile phone. And we kind of predicted that smartphone was going to blow up, but I don't think we really knew that iPhone and Android was going to be such a huge thing, to be honest. But we definitely rode that wave, and we partnered with Yahoo and released what we called Yahoo OneSearch, which was the first voice-based large vocabulary dictation over the network, and that enabled people to do, I think at the time, probably the vocabulary was about 50,000 words, and then when we do swamp language models, we could do 300,000 words, so that was quite large, and you really need that kind of large vocabulary to do web search, and so then from once we demonstrated we could do very large vocabulary voice search, we kind of moved toward more general interface. We always had that vision, and it was just kind of a stepping stone. So then we kind of competed with Siri, and Siri kind of joined the market from once iPhone and apps started. They were really text-based to start with, and we were more focused on speech recognition. But end of the day, we kind of morphed into each other's space, where we started to do more NLP to automate more tasks on the phone, and they moved into speech. And at one time, we actually powered their speech recognition before they switched to Nuance. And we actually had the option to continue to support their speech recognition, but we decided not to. So today, the Vlingo product is still preloaded to all the Samsung Galaxy phones as S-Voice, and it's shipped probably hundreds of millions of phones now that, across, when I last worked on it, was about 20 languages, maybe 50 different domains, but I think it's much bigger now. so we, you know, so there I started working on speech recognition, and then I switched to NLP about a year later, and I basically architected and built the whole NLP stack for Vlingo. And so that was acquired by Nuance in 2012, and I did not stay on at Nuance, and I started a new startup doing asynchronous task delegation. The company was called Pencil Labs, or WITH, WYTH, and that was funded by CRV, and then that was acquired by Airbnb 2 years ago, and that's why I'm here on the other coast. So, and at Airbnb, I'm part of the data science team, and let's see, I've been here about 2 years. I currently manage 2 teams specifically around the whole experience when our customers needs help. So both the self-help part and the agent help part. And so we do a lot of experimentation. We have machine learning based data products that support this whole stack of technology. And so yeah, things are good. And Airbnb is growing very fast, and we have a lot of very interesting problems here. So
yeah. So we've got now. Thanks for the introduction, Han. Super awesome. We've got a set of questions, and we've got a bunch of guys watching right now as well. I know John Pierce is there. Just calling out a few names. We'll have a chance for viewers Q&A in a bit. But I guess the big question, we'll run through the questions, but the big question is, does Airbnb, how much deep learning and AI does Airbnb use today? And
yeah.
what are the applications?
Yeah. So certainly let's say, there's a tremendous amount of growth at Airbnb. When I came to Airbnb, I think globally we were about 1,200 people, and now we're about 3,000. And in terms of data science, I think when I joined, maybe we were a little under 20 people. Now we're around 85. So the number of technical people has really grown. So at its heart, Airbnb is really a user experience design company and a technology company. And so we are very focused on, thinking about the ecosystem of this online marketplace for listings, for travel, and how technology can really support that online marketplace and make it better, and make the online market very efficient. And so one thing that's probably worth to note that when Airbnb first started, the number 6 hire was a data scientist, and he was economist by training, and he really dug into the data and started thinking about how do we use data at Airbnb, and he really injected a pretty strong data culture to make data-informed decisions at Airbnb ever since he joined. And so one of the very first things that he had done at the time was I think now Airbnb has about 3 million listings, and we are in 197 countries. So basically every single one except for Iran and North Korea, I believe. And
is that right? Every country except North Korea. You guys gotta get on it, man.
Yeah, I mean, we're in Cuba now, right? So we have thousands of listings in Cuba, and so it's so when we first started, the marketplace certainly was not this big, and so it was very focused on, let's say, 20 cities and a handful of countries. And so one of the things that he really first worked on is to understand, what's the market dynamics of these individual markets? Are we supply constrained or are we demand constrained? So then we can figure out whether, to invest on building more supply or building more demand. And so when we definitely, to create an efficient marketplace, we want the demand and supply to be matched. So through that analysis, we could focus on our effort on whether to grow demand and supply in what market, and that's how the data science team really got started. And today, basically we have this centralized model, and so we have a team of 85 data scientists, and then they're divided into individual product areas, and then all the data scientists in individual product areas sits with the engineers, product managers, and design, and other functions that focus on one product area, but administratively we're centralized, and we share learnings across the team, and we share best practices, we share a data foundation, and the tools are shared, the learnings are shared, but how the application to the individual product areas are decentralized. And so basically almost every product area has data science support, and we have so to answer your original question, how is machine learning used, and how many machine learning based data products are there? So the short answer is there are a lot. So I think one, kind of unlike one thing I see that's very different today is, let's say in the Vlingo days, this is not that far ago, 6 or 8 years ago, we tend to have companies that specialize in machine learning, let's say in one area. Like they may be specialized in speech recognition, they may specialize in natural language processing, they may specialize in image recognition, or one of a single kind of stack of technology. But today, I think, Airbnb as a technology company, we don't just work on one areas. Like, we have machine learning based models to support a number of things. Like, we do fraud detection from it. We do, how to optimize payment mechanisms, how to recommend prices to our host, how to improve our customer support, and and also, like, let's say, I mean, it's just many areas, like like search ranking, how to recommend listings, how to help hosts improve their listing. There is so where essentially any kind of human decision needs to be made, and repeatedly, and where we can automate. And so I think there are a lot more applications to come, and we certainly have invested in a number of areas that has the highest ROI. And so we prioritize all the time, and we really focus on the business metrics and thinking about where we can invest that will get the best ROI. And on the other side, I think as open source projects and as number of experts in in machine learning increases, the cost of deploying these things are just lower and lower. So I think we have, on one side, machine learning based data products are delivering both just key business metric gains that the company cares about, and on the other side, I think the cost of delivering these applications are lower. So I think that's why the number of applications is increasing dramatically, and and I think that's probably partly because the whole machine learning area is very, very hot.
So that's really interesting. I mean, it sounds like what you're saying is that the data science team and the machine learning guys are in some ways embedded and matrix to the engineering and the PM team, right?
Yeah.
And it sounds like a lot of the decision making in terms of what to use machine learning and what the applications are made at the edges, right? At the local team level, right? As they see fit, whether it's price recommendation or what have you. And one of the things that you and I have talked about offline before, and we're actually, this is related to a question I want to kind of sing back to the live chat question that Mark Schmidt had submitted, I think is on point here, which is, you guys do. I think one of the things that you said was you guys have the culture of doing a lot of A/B tests, right? That kind of is machine learning related, and then looking at how the KPIs have changed. The question is, how do you manage and track all these machine learning experiments in the company? And maybe talk a bit about the philosophy and what you have seen. You've been in a number of storied companies, right? Both big and small. I think it would be really interesting to kind of also hear as relates to that, and sort of like how does one of the leading companies in today, the leading startup big companies, think about experiments, A/B testing as it relates to machine learning?
Yeah. So I think so. First of all, after coming to this coast, or maybe the world is just changing. I think a lot of the Bay Area companies, probably some companies in New York and Boston are starting to do this too, which is set the kind of business metric that you care about, and kind of be aware what you can track, what you cannot track, and start optimizing for the things that you can track, and watch out for the stuff you cannot track. And then I think Amazon is run this way, Facebook is run this way, and Google to some extent is also run this way, and so setting up these goals, and I think the leadership basically says we care about these goals, and they're and one thing we actually found that's really interesting is instead of setting individual goals at the team level to have their own metric, like it's very easy to say, like, let's say let's give an example, right? Like, let's say for the search team, right? Like, we can just optimize for search ranking or like click-through rate, right? And so let's say the search team just talks about click-through rate, and let's say the search team only sets a click-through rate goal for their team, and so that's one scenario. And the other scenario, let's say the search team certainly can track the click-through rate, but they also track a common goal across the company, let's say related to revenue. Okay, so when they run the experiments on search, they not only track how well they're doing on click-through rate, but they also track how well they're doing on revenue, right? And revenue is a goal that can go across many, many teams. And when you talk about revenue, like, even though you don't know anything about search, right, you can say, hey, I improved click-through rate by so much. Like, other people who are not experts in search don't really understand how important that is and how hard that is to do. But where if you translate that metric to, let's say, revenue, right, it's very easy to understand, and then you have this single metric that kind of goes across many areas. Then it's also very easy to trade off resource allocation across these teams, right? Like, let's say the search team is doing really well, they optimize really, really well. The incremental gains that we can get from search to revenue, both in short term, long term, is has certain gain, and relative to other teams, maybe it's small. I mean, I'm not saying that's today, but as you invest in an area, you get better, and the gains kind of gets demolished, just demolishing returns. So these investment decisions need to be made like constantly. Depends on how well you're doing on the individual areas. So we really have, we have a culture of metrics, and we have a culture of having kind of single metric going across multiple teams, multiple areas where everyone understands. And you can still track other metrics to kind of support your specific areas. And then these investments gets made pretty easily. And so one thing is having this metric thinking and running experiments. As you change the search algorithm, you track your key search-related metrics, but you also track a common metric across.
How do you, as a follow-up, how do you guys, so you guys probably have a bunch of A/B tests running in parallel in different groups, right? That's, in different areas of the site. How do you guys make sure there's no confounding factors, right? That you guys can actually dimensionalize like what's actually causing what?
Yeah. So we have invested a lot in the experimentation platform, and very similarly
in-house
to
built.
Facebook.
It's you guys built it. You guys built it in-house. The platform.
Yeah, we have an in-house platform. So like at the beginning, we would run experiments, and like let's say the engineers would, the data scientists would design the experiment, and then an engineer would code it up, doing make sure the random assignments are correct, and then we log the signals. Then once the experiment is running, either we analyze it after some time, or we just kind of wait for a little while, right? So that's the old days, but now it's very different. So we kind of have almost boilerplate experimentation. So we have an experimentation platform, and like engineers. So if an experimentation is easy, right? So let's say we're running some user-based experimentation, which a lot of the experiments are, and we have lots of users. We never have any power problems really when we run these things, and if we have power problems, we just wait. And so we have the engineers are actually empowered to basically configure a few files, and then the experiment just runs, and the data gets logged, and it goes into our data warehouse, and the data is manipulated with our we have an open source project called Airflow that basically processes the data in a regular cadence, and then we extract key business metrics from that, and then we have a dashboard that basically shows live like how the experiment is running, and
That's
like
really
how
cool.
is it doing, and whether it has power or not. So engineers are empowered to just if they dream up an experiment that they want to run or some feature, they can just do this, and without much cost.
Yeah, and I think
we definitely have mixed assignment problems, but those things are basically taken care of automatically.
Sorry, go ahead.
So at any given time, we're running thousands of experiments.
Wow.
Things are going turned on and off, and that's why there's the downside where it's really hard to know when a user, let's say a user reports a bug, we don't actually know which we do know, but it's with a lot of effort, which version.
Yeah.
Basically anyone could change anything at any given time, and but we watch these metrics very closely. If things turn bad, they get shut off right away. So
interesting.
And so lots of things gets run quickly, and but data science does get involved when experiments are hard to run, right? Sometimes we have to run some market level experiments, and those things are really hard to run, and or some temporal based experiments. Those things are hard to run. So we still do manual analysis on those things, but majority of the experimentation is run very, very with low effort. And
that's interesting. I mean, this is powerful stuff, right? Because I think a lot of people don't think enough about. I think what you just talked about is thinking about instrumentation and the instrumentation itself, right? Where the way you guys have designed it over time is you guys actually don't have a lot of the obvious bottlenecks, right? With this, you've got all the teams at the edges that are, if they want to do the experiments, and you guys have a good abstraction level, abstraction layer from a data science standpoint, and the sort of the reporting and the actual guts of the data science, they can actually do it and pull you guys in if the experiments are complex. It's kind of what I'm hearing, and I think that's one of the thing that sometimes as engineers and computer scientists, right, we think about, all right, here's the problem, how do we apply machine learning to solve it? But sometimes it's actually more than that. Sometimes it's how do you design the instrumentation, and how do you actually design the organization to actually, make sure that it can move fast.
Yeah. Actually, you just kind of remind me, there's another thing that's pretty interesting is, I think Airbnb, with the three founders, two of them are from design school. They went to Rhode Island School of Design. the design sense is very strong at Airbnb, and the user experience focus is very strong. So one thing about experimentation, in the way I described, is you can end up with a site that just looks totally design-wise, aesthetic-wise, is just diverging all the time, right? Because you have people changing different things. Let's say the font is different, the color is not coherent. You definitely find sites like this where the experimentation culture is very strong, but then the aesthetics just kind of goes out of control, right? And we don't suffer from that, and it's very deliberate, right? And the way we kind of solve that problem is that we have a very strong design language, visual design language, enforced on the site, right? So engineers can change certain things, but if they change certain things in the visual part, they need to kind of partner with the design team and make sure everything is coherent.
Interesting.
And so it's there's definitely a lot of different issues to worry about, right? I think running these experimentation really help us to focus on, we don't have to make a decision about whether something is going to work or not, right? So if I don't I won't say who said this, but I remember talking to a director for another very big company. He said, in the old days, product managers would debate, saying, "Hey, here is my sizing for these two projects, and we should run this one versus that one, and the resources should be allocated this way." But in most cases, if you track these things, let's say half the experiments or half the things that you do don't pay off, right? Let's say your hit rate is 50%. That's probably pretty good anyway. But even if you ask a really experienced product manager or a team of committees to decide which of the 50% of the project are likely to succeed, you're really not doing much better than chance anyway. Yeah. So hopefully, so with experimentation, if things can just get implemented really quickly and run, you might as well just run it instead of thinking about, hey, which one is really going to pay off, right? And certainly you need to size it. Certain things, even at the most optimal case, is not big enough. Then you shouldn't do anything anyway, right? But we're talking about things where the sizing wise looks reasonable, but whether you think it's going to succeed or not, that estimate is pretty hard to get. And as long as the effort is not too high, just run it. So that's basically the culture. I mean, but there are things we have to make pretty hard decisions on, right? Certainly we are investing in a project that has kind of takes a long time and could potentially have high gains, and we have to be very deliberate about them. And so
interesting. We've got a few questions.
The decision is both. There are still manual component, but it sounds like you guys have automated for quite an extent. But the human is still in the loop to decide which features or certain functions should be moved forward. That's what you're saying.
Yeah. So I mean, at the end of the day, certainly I don't think. I mean, there's a lot of talk about whether we can. Let's say can we do machine learning? Let's say we have a model that can basically decide what product to build or what machine learning model to build, right? Like a meta machine learning thing. That I don't think we're anywhere near that today. So there's still a lot of I think the translation between business metric to machine learning based data products and how these data product will have some metrics coming out of it, and how that metric translates to the top line business metric is certainly not linear. And how do you invest in that? And when is the performance of the model? You have to decide, do I have enough data, right? You have to decide, is the algorithm good enough? And you have to decide, okay, is it going to move the business metric even when at its best performance? And so those decisions are pretty hard to make. And that's what a lot of the kind of expertise I think really comes in. And of course, there's a lot of work to even once you make that decision to get the data, clean up the data, train the models, and deploy it, and really design the metrics and monitor and making sure how do you do this iteratively and improve the models. That's still a lot of work, but there is a lot of expertise around setting up the problem and thinking about like what problems are worth investing. And I think unfortunately this particular problem is not something we train in school. Arthur, when you and I went to school for speech recognition, right? Like our professors basically said, "Hey, here's word error rate. Go optimize for that." Like I never questioned whether word error rate is the right metric or not.
But I have tons of questions.
But I think almost in this new world, we have to ask more about, hey, is word error rate really the right metric, right? Or for machine translation, is blue score the right thing? Can we design better things? How does that translate to the top line business thing? And like I guess in the Vlingo context, when we build our product, we definitely tracked parsing error, and word error rate, and even task completion rate, right, or number of turns for the dialogue manager. But we certainly didn't do enough about how do we measure the repeated usage from the user? Like when we improve these different performance metrics, is that really moving retention rate of our user? We didn't do the experimentation at that level. We certainly tracked at the performance of the model, but at Airbnb today we would certainly run these models and track user retention, right? So that's kind of the we would track all these things at different levels.
I guess one comment here is I think I have two comments. One is on the case of Airbnb. It's amazing that the whole experimentations is actually integrated into the platform, so it's rather easy to do A/B tests. And but when I hear from you, I think the part that still require human is let's say when you run thousands or 10,000s of tests.
Yeah.
How do you relate this individual metrics to your top line metrics such as revenues or margin, profit margin? And from what you tell me, there are some part of it is automated, but there's still a lot of part which is human.
Yeah, no, so I think you're probably referring to the attribution problem. We're running, yeah. So this is the power of A/B testing, right? Like if you run the A/B testing properly,
okay.
all these things are independent. Like even though you're experimenting on the same pool of users, you're doing as long as you're doing the random assignment, and let's say the effect that you're doing is not compounding. I mean that's a big assumption, and hopefully it's true. and then the attribution is the problem. So I mean I think the problem this is a pretty hard thing for someone who is not in this business to understand. I think let's say let me give you an example. Let's say on price recommendation, right? Like that product, right? We want to know one of the metrics we track is around how many what percentage of our hosts are actually adopting the prices that we recommend, right?
Okay.
And so we have a model. We are tracking that, and so I mean there's a bunch of other metrics we track, but this is certainly one we track. Let's say one we track, and so at any given time that team is probably running, let's say 50 experiments, right? And they all are moving this metric in different ways. And we have to know which experiment is driving that metric in what way and whether it's statistically significant. Otherwise, we don't know which experiment to continue and which experiment to deploy and which one to kill. And so at the heart of it, so just looking at the top, daily, we can certainly build a dashboard that says, hey, is the is this metric moving, right? It may be moving a tiny amount, right? Or it could be moving like completely flat, but it's possible like some experiments is driving the thing down, some of the thing is driving the thing up, right? And we have to know what's the net gain of each thing. And also when we're running these experiments, we're purposefully running, let's say, we're exposing it to 1% of the user, right? Like, so the effect is small, but hopefully, chances are they're going to be linear, right? We run it to 1% of user. We can extrapolate the fact that if we run it around the whole thing, what we would get. We will validate that, but, we run it slowly. And
I see a basis. I think the second comment about regarding speech recognition is I think it has to do with how speech recognition generally as a business. In the past, speech recognition is seldom sell as a software, as like a service. It has changed last 10 years, and so because speech recognition wasn't sell as a service, so it was harder to relate basic metrics such as word error rate or whatever passing error rate with something like revenue. So I believe this tendency will change, but now it is still not a trend. A lot of people still talk about word error rate. And,
no, I mean, if you're selling the speech recognition engine, you basically don't have choice, right? That's what you have to talk about. But you have to, but as the technology gets applied in the business context, right? Like, different application require different kind of performance curve, and sure, like, we always want something better, but is the last 5% really? Are you really willing to pay a lot for that last 5%, right? Like some application, it is worth it, and some of it may not be. So
I totally agree.
Yeah.
But sorry, I interrupt. Yep.
Yeah. One question we have here, I think it's a common one too, from Adit Deshpande, and I think it harkens to the fact, the generic fact that when you have any kind of machine learning black box, right? You get the black box effect of, here's the answer, the output, but you want to figure out, hey, how did they get to that output? How do you interpret that? Now, you guys may not have that problem. I'm curious if you guys have that problem, given the fact that you guys are tying this to observable or metrics business metrics that you guys care about, like revenue, click-through rate, and things like that. But is this a problem for you guys where you're like, hey, we got this answer from the machine learning black box. Let's peer inside and figure out what was the pathway that got to that?
Yeah, that's a good question. So I think in some applications you care, and some applications you don't.
Yeah.
And I think you have to be very cognizant, like the application you care and which one you don't care. And when you care about why is the model making these decisions,
right.
Your algorithm choice is going to be different, and your feature space might be different, right? Like, so only take that constraint if you really need it, right? Like, for example, let's just use pricing as an example, right? Like, let's say we have this model that basically can predict pricing and recommended price for the host. And one option is we can build a model and we just say, hey, this is what we recommend. And let's say, we think that's good enough, we can just build this model and try to optimize that and maximize the, top line metric. But, one thing one probably could realize is, we probably can convince the host to change their prices if we tell the reason why we recommended these prices, right? Instead of just saying, hey, the machine recommended this price, like if we can give a list of reasons, at least top reasons, and so by providing that feature, there is value, right, to the customer.
Yeah.
And so once you realize that, you say, well, my model choice is probably going to have to change. I can't use a black box, right? Like, so I'm just giving that as an example, what we actually do behind the scenes.
Yeah.
not correlate to what I'm saying. So.
Yeah. No, I think it's a very generic problem. I don't think there's necessarily a solve all answer here, but that's interesting. Switching topics a little bit, we may come back to this in a bit, but I know Han, you spent a lot of time before this, and you spent years in the NLP and speech recognition space, both academically as well as at Vlingo and SpeechWorks. Taking a step back, how do you think about the last few years of deep learning impacting speech recognition and NLP? Where do you think the state of the art is, and where do you think it's going? I think a follow-up question there is, I think, you and I used to joke, before deep learning came on, the speech recognizers used to be at least commoditized, right? What was not commoditized were the models on top. I'm not sure if that's, I'm not sure if that's true anymore. I'm curious to kind of hear your thoughts now with, deep learning in the space and kind of the various frameworks and algos out there. Is there still much more to be squeezed out of speech recognition, and then correspondingly on NLP, where do you see that's going?
So let's maybe talk about speech recognition to start with. I think it's pretty clear that deep learning has changed the field dramatically, and I think let's say speech recognition has a pretty long history, but we can probably pretend it started in the 1980s, and with the first HMMs. I mean, there definitely worked before that, but the performance curve have improved kind of gradually and before deep learning, and there's probably a handful of things that really made a difference. And at these jumps that the relative performance gain, let's say, was like 5 to 10%, something around there. We can just name a few things like HMMs or MFCCs or like MMLR for speaker adaptation, then discriminative training, and better language models, how to do smoothing. All these things contributed to like the performance gain, and by themselves, each probably was like 5 to 10% relative. And when you add these 5 or 6 things together, the gain is pretty big, right? And but these kind of gains came maybe, I'd say, every 3 or 4 years or so, so over the last 20, 25, 30 years, we made significant gain. But for a while, I think because we only get this kind of 5 to 10% gain every, 4 or 5 years, I think from a practitioner at doing that time, it seems like progress was pretty slow, I would say. And I think more recently with deep learning, that because the deep learning technology can be applied on the feature extraction side, for the modeling side, for the language model side, and then combining them, and so there's a lot more things to play with. And I think the kind of gains that we're getting, because this set of technology that's available is much more dramatic. I think like the gains that were where for MMLR you can like the initial gain, let's say, was 10%, and you could optimize that. You could maybe squeeze another 2% out of it, and that once that's done, you're really basically done. Like you can't really use MMLR to get more. But where I think for deep learning, one thing that's been really different is I think people started, let's say, applying to the language modeling part, then they applied to the acoustic side, now they're changing the HMMs, modeling structure, and now they're thinking about how to like combine all of them, right? Like to stack them together. And every time this happens, we're seeing pretty dramatic gains. So like, I don't think we're seeing 5 to 10% relative gain every 4 or 5 years, where the pace is much faster. And I think at some point we'll run out of these gains, but and we're not done yet. And so I think that's how really deep learning has changed this field. So I think if you're working on speech recognition, if you're not applying this set of technologies, you are going to pay a 20 or 30% relative performance gain. And if you can live with that, that's fine. But if you cannot, you really need to do better. So.
Yeah, that's really cool. I think, yeah, no, that's actually a interesting insight. I mean, which is, I mean, it's been a game changer, right? I mean, it's all the incremental tweakings and tuning, 3-4% every so often, and this feels like it's a whole different level. And right, once that tuning at a whole different level gets exhausted, it may be good enough for most applications now.
Yeah, and I think that because of that, I think the entrenched player's advantage is relatively small. I think, let's say Nuance invested many years in HMMs, and I think even FS like finite state transducers kind of changed that world. Where I think Google's speech team was able to build a speech recognizer relatively quickly, much faster than, let's say, IBM or BBN in their early days, where they spent many years optimizing search, optimizing the code base, where, I think Google's path was definitely more like, hey, let's build this FST library, optimize the crap out of it, and then let's build a speech recognizer on top of that, and then we pump some data, we got a great speech recognizer. And I think without that set of technology, Google wouldn't really win in that space this quickly. And also, I think with this new iteration of deep learning, like some of the more basic expertise that learned previously is not such an advantage anymore. So where, if you figure out how to apply deep learning to this new this set of problems, you can really make dramatic gains against the incumbent players. And so that's another thing that's pretty important. So
I've got a couple other questions relates to AI, but we do have a question from the audience from Zubair. What language do you guys use mostly? R, Python, others?
Yeah, so for the data science team, we're pretty agnostic to R and Python. So like we probably half the people use R, half the people use Python, and some maybe let's say 25% of people use both.
That's good.
And so we have infrastructure that supports both. And then for the engineering team and also some data scientists, we also write Java code and Scala.
Yeah, got it. Okay.
And our front end code is in Ruby on Rails. But
really?
Yeah.
The entire front end is Ruby?
Yeah, Ruby.
Oh, interesting. Oh, cool. Would not have expected that, but very cool. Going back to AI and again, I think it bears repeating that Han, is in the belly of the beast in Silicon Valley. We have an ongoing threat in our group whether how overhyped AI is. It feels like this is 19. For those old enough to be around in 1998, when every company needs to have a website, and there's this thing called HTML and this thing called HTTP. How overhyped do you think it is, and what are you seeing in Silicon Valley, just thematically, as far as AI is concerned?
Yeah, I mean, I guess it's hard. I mean, first of all, certainly there's a huge amount of investment going into this area, and by the number of conferences and the people who are attending and the people who are coming in learning about this area, it's pretty dramatic increase, and it's not slowing. And I think it's hard for me to say whether it's an over investment or not. And I think I think we're certainly not done. I think in terms of application of machine learning to change business models, I think I do think essentially any business today that doesn't use machine learning probably will start using it.
Yeah.
in 5 to 10 years. And like we're starting to see it in customer service, how to do analytics, like Arthur's company, and I think as kind of non-technology based as sales department is, it's also getting there, right? Like understanding like how salespeople should spend their time, like kind of a hybrid human and machine based model could dramatically improve like business process, and I think there's many like things could be done in all the sectors of the economy, and I think how like at its base we have the computation power to support it. We have the ability to log this huge amount of data pretty cheaply and store it and processing them. But then then we have open source project or algorithms that can support getting these models built. Then another layer is expertise around how to think about how to change these business models, how to inject ML into these business processes to improve the overall. And I think the first two problem is pretty easy. I think like we're just making investment in these areas. We'll probably get the power curve improvement there, just on its own. But like I think the top problem is actually a very difficult one, because what I see is often you have this problem where the machine learning people or the people who are really familiar with the technology don't understand the business process. Wow. Like and then the people who deeply understand, let's say, sales, don't really have any understanding of machine learning.
Yeah.
So what's the model here? Is the model that we take someone who is the business expert in that business process, partner with the technologist. So let's say the two founders startup trying to disrupt an area. So that's one model. Another model could be machine learning is so easy to learn that a lot of people know it, and then they can also pick up the domain expertise. Or the other way around, someone who has domain expertise can like figure out most of it and then partner with someone in machine learning. I think that's really the hard part. And I think one thing maybe as technologists we can help facilitate that process is really understand takes any daily business problem and trying to think about, hey, what metrics should be measured, and is there what can we use machine learning or what can we use data product to improve that business process, and like talk to the business domain expertise and say, hey, what can be done here? And I think that partnership is really needed to make this evolution happen. And I think that probably is the bottleneck. So that marrying of these two groups of people together and solve these areas with deep insight, and I think I often see startups either with domain expertise or with machine learning expertise, but not with both. And because people don't meet up that often, right? Like this cross-pollination happens pretty rarely. So, if I was an investor, would I invest in one versus another? I don't know. Like it's hard, and I think I would probably rather invest in a team that have both, and that's really hard. And trying to if they can, these teams can be built and that if they really have some deep insight about how to change the business process with technology, and that's where really the game is, I think. So
interesting. We're coming up on the hour. We've got a minute left, so I want to just use the remaining minute to thank Han for taking time out of his busy schedule to join us. Thanks so much. I really appreciate your insight and your thoughts in this. And I think on behalf of the group, thank you. We have a lot of the answers, the questions answered. So hopefully at some point again you come back and join us. And thank you.
Well, thank you for inviting me, and we've been longtime friends, and you guys are running a great group, and I think this area for machine learning and deep learning is super hot, and can be applied to a lot of areas, and there's a lot of potential. I think more people getting into it, and more people know this technology and also understand deeply about business process in specific areas could really make the world a better place. So.
We try, huh? We try.
All right, guys. Thank you. Have a good day.
Great.
Bye.
Bye-bye.